Hi, my name is Sir Waish. This is the part 2 of sentiment analysis using Python. In previous video I have already explained first half of the code. You can access part 1 video from description. Let's begin part 2 from here. Here, we're preparing our data by converting our text inputs into binary vectors using count vectorizer. The fit method is used to learn the vocabulary from the training text data, and the transform method converts the text data into numerical vectors. Now, we split our data into training and validation sets using the train_test_split method. This ensures that we have separate data for training and testing our sentiment analysis model. We import logistic regression from scikit-learn, which is our star of the show, and we also bring in accuracy_score to evaluate the performance of our model later. Next up, we split our data into training and validation sets using the train_test_split method. This ensures we have separate data for training and evaluating our sentiment analysis model. Now comes the exciting part. We are training our logistic regression model with different regularization strengths, represented by the parameter C. Regularization helps prevent overfitting and improves model performance. We loop through various C values and check the accuracy of our model on the validation set. And finally, we make the ultimate prediction on a specific data point and compare it with the actual label. Firstly, we access the index 29 at test label and predict it using logistic regression. Here we print the test label at index 29, and here we print the test text at index 29. Here, we take it one step further and visualize the accuracy of our model based on different C values. We use matplotlib to plot a graph showing how accuracy changes with each C. It's fascinating to see how the model performs with varying regularization strengths. This code uses matplotlib to create a bar plot showing the distribution of labels, negative and positive, in the train_labels data. This code compares the distribution of labels, negative and positive, between the train_labels and test_labels datasets using a bar plot created with matplotlib. It calculates the label counts for both datasets using np.bin_count, and then visualizes the comparison by plotting two side-by-side bar graphs. Each bar represents the count of the respective label in the train and test datasets. The x-axis shows the label categories, and the y-axis represents the count. The legend distinguishes between the train and test data, making it easy to see the label distribution differences at a glance. This code calculates the lengths of all the texts in the train_texts dataset and creates a histogram to visualize the distribution of text lengths. The histogram displays the number of texts falling into different length bins, divided into 30 bins. It provides insights into the spread of text lengths, helping us understand the variation in the dataset and identify potential patterns or outliers.